We have a few friction examples that we want to do with you today, starting off with one that you should be pretty familiar with, one that we've worked on a few times over the last couple of days. This one says a 30 Newton force is required to cause a 10 kilogram object to begin to move. Calculate the coefficient of blank friction between the object and the floor. So the first part of this question is asking you what type of friction it is. Are we looking for the coefficient of static friction or the coefficient of kinetic friction? In other words, are we finding this measurement of how much two things stick together when we're trying to get it moving or when it's already moving? What is it? What am I going to fill in that blank with? Yep. It's not kinetic. No, it's going to be static friction. Okay, the reason it's going to be static friction is because we're trying to get it moving, right? 30 Newton force is required to cause it to begin to move. We can't find any kind of coefficient of kinetic friction with a force that's required to get it moving. Okay, if we want a force here, it would be the force required to keep it moving, not to get it moving. Does that make sense? Okay, the next question is going to illustrate just the opposite, where it is kinetic friction. You're going to see the difference between that, hopefully. Okay, if it doesn't make sense to you, then make sure you let me know so that we can spend a little bit more time on it. Okay, so this force of 30 newtons is required to get it moving. That means that we have to just exceed the maximum force of static friction. In other words, I push with 30, it starts moving. That is the maximum force of static friction. Remember how that works? If the maximum force of static friction is 30, I push with 10, doesn't move. Friction is just 10. I push with 20, doesn't move. Friction is just 20. I push with 30, it barely begins to move. Okay, that means the maximum force of static friction was 30 newtons before it began to move. So let's write that down as a given here. FSF max is 30 newtons. That doesn't mean that's the force of static friction. That means that's the maximum possible force of static friction. Static friction could be 6 if all I push with is 6. But I can push with up to 30 before it begins to move. We get a mass of 10 kilograms here. And we're looking for the coefficient of static friction. The only equation I know with coefficient of static friction in it is this one. We're going to say FSF max is equal to mu times the normal force. For us right now, this has been the case for all the questions we've done so far. The normal force is equal to what? M times G. So let's rearrange this, solve for this. We know FSF max right now, and we can find Fn by saying M times G pretty easily. We're going to say FSF max is 30 newtons, divided by Fn, which is 10 times 9.81. That's 30 divided by 98.1. That gives me a value of 0.31 with no units. So like I say in this question, we're not given a particular force of friction. Okay, maybe the force of friction is 10, maybe it's 20, maybe it's 13, maybe it's 29. We're just saying this is the most it can be. How do I know this is the most it can be? Because this is what's required to overcome it. If I need to push with 30 newtons to overcome static friction, then that must be the maximum possible value of static friction. Does that make sense? Okay, let's have a look at another question. It's a little bit different, similar in terms of difficulty, but a little bit different in terms of how it's worded. Okay, let's have a look at this one now. This one says a force of 40 newtons is required to keep a 10 kilogram object moving at a constant velocity. Calculate the coefficient of blank friction between the object and the floor. What would this one be, static or kinetic friction? Yeah, this would be kinetic friction. This object is clearly moving. We're not trying to get this object moving. It is moving. Now, understand that this 10 kilogram object is moving at a constant velocity. If it's moving at a constant velocity, it's in a state of what? What's that E word? It's in a state of equilibrium. When it's in a state of equilibrium, forces must balance, right? If forces balance, and I get a force of 40 newtons acting forwards, then I must have a force acting backwards that is 40 newtons, right? Otherwise, it wouldn't be in equilibrium. Well, the force acting backwards is friction, kinetic friction, because it's moving. All right, Well, if the force of kinetic friction is 40 newtons, let's write that down. This one's different than static friction. When I wrote down my value of static friction in the last question, that was my maximum possible value. Static friction could have been less, it just couldn't have been more. When I write down my force of kinetic friction, it's not the maximum possible value, it's the value. If it's moving, this is what kinetic friction is. Not less, not more. Let's write down the mass here is 10 kilograms. And we're looking for a coefficient of kinetic friction. It's moving at a constant velocity. Forces must balance. When forces balance, friction is going to be the same as the force that's pushing it forward. All right, let's write down my equation now. Force of kinetic friction is mu kinetic times Fn. Let's rearrange that. I get FKF divided by Fn. I get 40 newtons divided by 10 times 9.81. That's going to be, I don't know, around 0.41. Thank you. Thank you, 0.407. That would be 3 digits, right? Last question we had 2 digits, 3 digits, final answer should be 2. In this question we have 3 digits, final answer should be 3 digits, 0.407. Here's another one. This is remarkably like the quiz question that you're going to get on Wednesday. No, sorry, tomorrow's Wednesday, on Thursday. Remarkably like the quiz question that you're going to get on Thursday. This one says, a 10-kilogram object is pushed on a flat horizontal floor with various forces as given below. The coefficient of static friction between the object and the floor is 0.75, and the kinetic friction coefficient is 0.50. What's the force of friction if we push with 40 newtons, 60 newtons, 80 newtons, 100 newtons, and 19,176.4 newtons? Here's the question. Does it move? Well, we got 5 different questions here, really, right? Does it move in A? Does it move in B? Does it move in C? Does it move in D? Does it move in E? How do we know? In order to move, we have to overcome the maximum force of static friction. Remember, in question 1 that I gave you here earlier today, you were given the force that was required to overcome static friction. That was FSF max, the maximum possible force of static friction. We don't have that value here. Let's get it. Let's get the maximum possible force of static friction, and then let's see if I'm pushing hard enough to overcome static friction. Let's do that up here. SFF max is equal to mu times the normal force. We're looking for the coefficient of static friction here, which is 0.75. Times the normal force on a flat horizontal surface is 10 times 9.81. Thank you, Luke. 73.575 newtons. That's not my answer to any of these questions, right? This is my maximum possible force of static friction. I'm only using this number to determine if it moves or not. Does it move? Well, question A, I apply a force of 40 newtons. If I push on it with 40 newtons, but static friction can be as big as 73 newtons, does it move? Luke? No, it doesn't. So that means if it doesn't move, then I've got static friction, not kinetic friction, and the value of static friction will simply be the value that I push with, 40 newtons in this case. Remember static friction? FSF. We could also call it not force of static friction. We could also call it stubborn force. It's the stubborn force that pushes harder as I push harder. If I push with 30, it pushes with 30. I push with 40, it pushes with 40. It just wants to taunt me. I push with 60. Does it move? No, how hard does friction push? 60. The force of static friction would be 60. Notice the difference here? These last two numbers that I've written down for A and B, that's not FSF max, that's FSF. That's the actual value of static friction force. The maximum value is 73, but it's not reaching 73 because that's not how hard I'm pushing. I push with 80. Does it move now? Does it move now? Yes, it does. Okay, it moves now. So now I've got kinetic friction, right? Not static friction. I don't know what kinetic friction is. I'm going to find that by saying it's mu times the normal force. But make sure you use the right value of coefficient of friction. It's going to be 0.50. Coefficient of kinetic friction times the mass, which is 10 kilograms, times 9.81, gives me 49.05 newtons, or we're going to round that to 2 digits. I get 49 newtons. So here's what happens. I push with 40, doesn't move. Friction is 40. I push with 60, doesn't move. Friction is 60. I push with 80, it moves. I've got kinetic friction, and it goes down to 49. Remember what we said about static and kinetic yesterday? Static is the maximum static is bigger than kinetic. Push with 100 newtons, does it move? Yeah, okay, so it's FKF again. Do we have to calculate that again? If you push with 80 newtons, it moves. Friction is 49. If you push with 100 newtons, it moves. Friction is 49. Okay, the kinetic friction force is not quite so stubborn as the static friction force. Static friction, as I push harder, it pushes harder. Kinetic friction, it's happy just being what it is. It's happy with itself. If it's 49 newtons, it says, I'm good with being 49 newtons. You push harder, go ahead. I'm still going to be 49 newtons. I push with 19,176.4 newtons. Does it move? Jen, does it move now? Yeah. So I've got kinetic friction. Jen, what's the value of kinetic friction here if I push with that force? 49 newtons. Doesn't matter how hard I push, kinetic friction is going to be 49 newtons as long as it moves. As opposed to static friction, which, well, static friction, the more I push it, the harder it pushes back. Have a look at this one. This one's taking it up a step here. This time we have an object on a hill, an inclined plane, 10 kilogram object, just like we have had in the past, right? Except that this time there's a coefficient of friction. It's kinetic friction, moving. Coefficient of kinetic friction of 0.30. We want to find the acceleration of this object. I want to give you a few minutes on your own to try to find that, see what you can do, and then we'll do it as a class after you've had a legitimate chance to do it yourself. Okay, let's have a look at this. We know that we have a force of gravity acting down on the 10 kilogram object. Let's call that Fg. And we know that we have a normal force acting not like this. Okay, we don't draw it like this because that's not 90 degrees. In physics, normal means perpendicular or 90 degrees. A normal force must be perpendicular to the surface. So that's the normal force, perpendicular to the surface. Now, it has to be drawn just right, just the right length, so that F parallel is actually parallel to the hill. Otherwise, F parallel is a terrible name for it. It's parallel to the hill. Let's find the value of F parallel right now. Let's worry about the coefficient of friction and what that's going to do for us later on. F parallel up here, we're going to say sine 30 degrees is equal to F parallel, that's opposite, over hypotenuse, which is m times g, the force of gravity. F parallel is 10 times 9.81 times sine 30 degrees, or F parallel is equal to 49.05 newtons. Okay, let's block that off. Okay, let's label F parallel here as 49.05 newtons. Now, if F parallel is that force pulling it down the hill, in the absence of any other force, it's going to go down the hill. But friction acts as well. Which way is friction going to act, down or up? Up. It's moving down the hill. Friction is going to act up the hill, right? How big is it going to be? I'm not really sure yet how big it's going to be. Let's just draw it up the hill here, label it FF. What's the value of FF? Well, it's mu times the normal force, right? What's the normal force? We know what mu is. It's 0.30. What's the normal force? 10 times 9.81, right? Wrong. What's Fn, Haley? Not sure? At least you knew it wasn't 10 times 9.81. The normal force is not 10 times 9.81 because it doesn't balance gravity. Look, they're not even in the opposite direction, let alone the same magnitude. We've got to find the normal force here. Any suggestions as to how I can find the normal force? Hint, it's not m times g. You could do the Pythagorean theorem, yeah. But if you do that, you better hope that you got F parallel correct. I'm going to do a trig function, which does not require me to have gotten F parallel correct. I'm going to say cosine 30 degrees is equal to adjacent over hypotenuse, Fn over m times g. So Fn is therefore going to be equal to m times g times cosine 30 degrees, or it's going to be equal to 10 times 9.81 times cosine 30 degrees, or Fn is going to be equal to 84.95709 newtons. Let's label that here. 0.30 times 84.95709 gives me an FF of 25.4871. Make sense? So F parallel is pulling it down the hill with 49 newtons, but there's a force of friction that's opposing that motion of 25 newtons up the hill. It's going to still accelerate down the hill, but it's not going to accelerate down the hill as it otherwise would in the absence of friction. Now let's straighten this out. We have a 10 kilogram object right here. We have F parallel right here, which is 49.05 newtons. And we have force of friction right here, which is 25.4871. Now you can do this question, right? Now this question is easy. Now we just say F net is equal to the sum of the forces. F parallel plus FF. M times A is equal to the sum of the forces. M is 10. A is what we're looking for. F parallel is negative 49.05, and FF is positive 25.4871. When we combine those terms on the left-hand side, on the right-hand side, then divide it by 10, we get negative 2.4 meters per second squared. This is exactly the same as we've been doing for a couple weeks now. The only problem with this is that we didn't know what F parallel was, and we didn't know what FF was, so we had to go out and find them. F parallel wasn't so bad because we've done that quite a few times as well. F parallel was just m times g times sine theta. But FF, we've done that quite a few times too. It's mu times Fn. But we didn't know what Fn was, so we needed to find that. Fn was the adjacent side of that triangle, so we used the cosine function to find it. That makes some sense? It's a tough question, hey? It shouldn't be as tough now, though, now that we've gone through this. Okay, in the end, just what I want you to take away from this is that the normal force is now not always m times g. Sometimes there'd be a normal force other than m times g. If it cancels gravity, then it's mg. If it doesn't, like here, then it's not m times g. When everybody's finished writing this, I'm going to give you another question. It's going to look completely different than this. What it's going to have in common with this question is that gravity will not cancel m times g. So you're going to have to find the normal force. To do Ff is equal to mu times Fn, you're going to need to find the normal force. It's not m times g. All right, here's another one. Calculate the acceleration of the object below. This time we're pulling an object. It's like a wagon, right? Pulling it to the right with 100 newtons and then go 30 degrees. There is a force of friction acting to the left. We're going to say that this wagon does not move up into the air, right? So it moves horizontally. We've done questions like that before, except we haven't done questions like that before with a coefficient of kinetic friction. Let's assume that it moves. You're going to have to find the coefficient of kinetic friction by saying mu times Fn. And a little hint here, Fn, as in the last question, Fn does not cancel with m times g. You're going to have to figure out what that value is. All right, let's have a look here. We've got a force of gravity acting down on this. And whoops, it's not Fn. Fn is acting up. Force of gravity acting down. And we've got a normal force acting up here. That normal force and gravity don't cancel each other out. They are opposite in direction, but they're not equal in magnitude. They help cancel each other out, but not completely. Now, it doesn't move up or down, so something's got to cancel up and down. It's not Fg and Fn, however, it's Fn and Fy combined. The total upward force equals the total downward force. So what we're going to say for this is Fg acting downward is equal to Fn acting upward plus Fy acting upwards. All right, the value of Fg is 20 times 9.81, which is 196.2. 20 times 9.81. The value of Fn, I don't know what that is, so I'm trying to find here right now, plus Fy. I don't know what Fy is. All right, so let's go over to the side here and do our thing to find the value of Fy. Let's say sine 30 degrees is equal to opposite, which is Fy, over the hypotenuse, which is 100. Fy is equal to 86.6 newtons. All right. If y is 86.6 newtons, and Fg is 196.2, if I take the 86.6 over to the left-hand side, sorry, that is wrong, thank you. That's going to be, that should be 50 newtons, right? I was doing cosine, I think, right? That's going to give me an Fn value. It makes the math a little bit easier here, at least. 196.2 minus 50 gives me 146.2 newtons. All right, now we have the value of Fn. Good. What value is that to us? Braden, what value is that to us? What are we going to do with Fn? Yeah, if you want to find Ff, it's going to be mu times the normal force here. So we're going to say the force of friction is 0.40 times the normal force, which is 146.2. 0.40 times 146.2 is, Braden, you have that one? 58.48. It is going to be negative. I'm not going to worry about the negative until I actually sub it into an equation there. Good, good, excellent. We've got that force to the left, 58.48. That's the hardest one, is to get that force of friction. The reason being, normal force isn't what we're used to the normal force being. That's 2 questions in a row now. Okay, now let's find the x component of this. Let's say cosine 30 degrees is equal to the x component over 100. The x component is going to end up being 86.6 newtons. Right, Luke? 86.6 for the x component. Yeah, so now let's write that in. Remember, this canceled with this and this. So all I've got left is friction in the x component now. Let's say F net is equal to FF plus Fx We're going to say m times a is equal to ff plus fx. We're going to say 20 times a equals negative 58.48 plus 86.6. You add those up on the right-hand side, divide it by 20, and when you do that, I believe you get 1.4 meters per second squared. So what makes this question the same as every question that we've done for the last 2 weeks? This. That's what makes it the same. What makes it different? Well, what makes it different, we need to find fx doing this. We've done that a few times, right? We need to find the force of friction. We need to calculate the force of friction. But in order to calculate the force of friction, we also need the normal force, which we're going to find from finding Fy. So a few things different about this, but it's logical though, right? Just find things. Like, you notice my strategy here? When I was going through this, I'm like, oh, I know the normal force and Fy combined to cancel out Fg. Okay, we can find Fn. Okay, we can find the value of Fn. Oh, now that I have the value of Fn, okay, now I can find Ff. All right, well, now I can get Fx, and then I can just combine Ff and Fx to get the acceleration. And there I go, done.